This is homework chapter 4. We will be solving problems 1, 2, 8, 10, 19, 24, 28, and 41. Problem 1 reads, 2 dogs pull horizontally on ropes attached to a post. The angle between the ropes is 60 degrees. If Rover exerts a force of 270 newtons, so Rover is 270 newtons, and Fido exerts a force of 300 newtons, find the magnitude of the resultant force and the angle it makes with Rover's rope. Okay, Rover is going to be force A and Fido is going to be force B. So force A, which is this guy, sub X is going to be equal to plus 270 newtons. Force A sub Y is going to be 0. And Fido, he's force B sub X, is going to be equal to 300 newtons times cos of 60. And force B sub Y is going to be equal to 300 newtons times sine of 60. And that's going to be equal to 150 newtons and 260 newtons, respectively. And adding up our forces of the X and Y direction. So this resultant X is going to be equal to 270 newtons plus 150. And that's going to be 420 newtons. And the resultant Y is going to be equal to 0 plus 260 newtons. That's going to be 260 newtons. And now we want to find the polar coordinates, so we'll go ahead and do that. Let me get some board space. Okay, so our resultant is going to be equals the square root of r sub x squared plus r sub y squared. It's going to be the square root of 420 newtons, quantity squared, plus 260 newtons, quantity squared. And our resultant magnitude is going to be equal to 494 newtons. Oops, I forgot the 4. There it is. And the tangent inverse of y over x, which would be 260 newtons divided by 420 newtons, that's going to be equal to 31.8 degrees. That was number 1. Problem 2 reads, to extricate an SUV stuck in the mud, workers use 3 horizontal ropes, producing the force vectors shown in that figure that I drew right there. Find the X and Y components of each of the 3 poles. Use the components to find the magnitude and direction of the resultant of the 3 poles. Okay. Okay, force 1, F1x equals F1 cos theta equals 844 newtons. So that's 985 cos 31. So that's 844 newtons. F1y equals F1 sine theta, and that's going to be 507 newtons. Now F2. We're going to use this angle, which would be 58. And so we're going to have F2x equals, that's going to be a negative 788 newtons times cos 58. And that's going to give you negative 418 newtons. And F2y is going to be positive. That's going to be 788 newtons times sine 58. And that's going to be 688 newtons. And you might want to know why I didn't use 32 as indicated on the diagram, but I like to do these problems with respect to the x-axis, just so I can keep everything consistent. If I would have used 32, the cosine would have been the y component and the sine would have been the x component. And it's just a lot easier for me to keep it, just to keep it consistent. Finally, F3x is going to be in the negative direction. That's going to be equal to 411 newtons times cos 53. And what do we have here? That is negative 247 newtons. And F3 of y is also going to be negative. Let me put my negative sign there. Negative 411 newtons times sine of 53. And that's going to be equal to negative 328 newtons. Now I add up my x and y components. So if I'm going to get my resultant x is going to be adding them up 179 newtons. And my resultant of y is going to be equal to 847 newtons. And so now I'm just once again converting to polar. I'm going to have my r is going to equal to the square root of 179 newtons, quantity squared, plus 847 newtons. I forgot that 7 there. Newtons quantity squared. That's going to be 866 newtons. And for the angle tan inverse of 847 divided by 179 is going to give me an angle of 78.1 degrees. That was number 2. Number 4, chapter 4, number 8 reads, you walk into an elevator, step onto a scale, and push the up button. You recall your normal weight is 625 newtons. So weight equals 625 newtons. Draw a free body diagram. A, when the elevator has an upward acceleration of magnitude 2.50 meters per second squared. So A is going to be 2.50 meters per second squared. That's for A. What does the scale read? If you hold a 3.85 kilogram package by a light vertical string, what will the tension in the string be when the elevator accelerates as in part A? Okay, so I need to find my mass. My mass is going to be equal to my weight divided by 9.8 meters per second squared. And that is going to be 63.8 kg. So for the first part A, I need to know my total, what am I finding? The total force upwards is going to be my weight plus ma. So it's going to be 625 newtons plus 63.8 kg times 2.50 meters per second squared. And for that, I am going to get, let's see, 784 newtons. Now, for my second one, I'm going to use my weight plus m of me plus m of package. Is that what I'm doing here? Yeah, plus times acceleration times a. So it's going to be 625 newtons. Oh, wait. Yeah. Plus a, this is going to be the mass of package plus g right there too. Plus 63.8 kg times 2.50 meters per second squared, plus the package. This is me, my weight, plus the acceleration due to the elevator, plus the package, which was how much? 3.85. Wait a minute, am I going up? Yeah. Am I just doing the package? Oh yeah, I'm only doing the package in part B, so excuse me for that. Let me erase that. I just want to know the tension in the string of the package, so I don't need my weight. All I need for the package, I'm holding the package by string, so let me go ahead and revamp that. That's going to be 3.85 kg plus 9 times 9.8 meters per second squared, plus that 2.50 meters per second squared. And that's going to give me 47.4 newtons. And I know it seems weird that you're going to weigh more when the elevator goes up, but you press down on the floor harder, even though the acceleration to gravity is going down, but the accelerator is going up. That means you're just pressing down on the floor harder. All right, that was number 8. Chapter 4, number 10 reads, a dock worker applies a constant horizontal force of 80 newtons, 80.0 newtons, to a block of ice on a smooth horizontal floor, and that block of ice implies no friction. The friction force is negligible. The block starts from rest and moves 11 meters in 5 seconds. So 11 meters, that's delta x, and delta t is 5 seconds. Okay, what is the mass of the block of ice? That's A, and if the worker stops pushing at the end of 5 seconds, how far does the block move in the next 5 seconds? Okay. All right. All right, so we need to find the acceleration. So we've moved 11 meters in 5 seconds. So x equals 1/2 at squared. So 11 meters equals 1/2 times a times 5 seconds quantity squared. A is going to be equal to 22 meters over 25 seconds. And that's going to be, let's see, 0A equals 0.880 meters per second squared. Now I need to find the mass of the block of ice. Let me get some board space. All right, so F equals MA. All right, so 80 newtons, oops, there. 80 newtons equals M times 0.880 meters per second squared. M is going to equal 90.9 kgs. 90.9 kgs. All right. Now I need to solve for how far the block moves after the push stops. So we need to get the velocity here. So we're going to do V final equals V initial plus acceleration times time. Starts from rest, so V final is going to equal to 0 plus acceleration was 0.880 meters per second squared, and the time was 5 seconds, 5 seconds. And we're going to get a value for the final velocity of, let's see, 4.4 meters per second, 4.4 meters per second. And let's see, X final equals X initial plus V naught T plus 1/2 AT squared. This term goes to 0 because there's nothing going on after that. And I'm going to give this term 0. So X final equals 4.4 meters per second. And what was that? The next 5 seconds times 5 seconds. And that's going to be 22, right? 22 meters, 22.0 meters. All right, that was number 10. Number 19 reads, at the surface of Jupiter's moon Io, the acceleration due to gravity is 1.81 meters per second squared. So G on Io is 1.81 meters per second squared. A watermelon weighs 444 newtons at the surface of Earth. What's the watermelon's mass on Earth's surface? What would be its mass and weight on the surface of Io? Okay, so weight of a watermelon is 44.0 newtons. And that's really weird because my mom is cutting a watermelon right now. So anyway, anyway, I digress. All right, the mass on Earth. M equals weight divided by G. So mass is going to be equal to 44.0 newtons divided by 9.8 meters per second squared. And that's going to be 4.49 kgs, 4.49 kilograms. All right, now the mass on Io is going to be exactly the same, but the weight on Io is going to be 4.49 kgs times 1.81 meters per second squared. And that is going to give me 8.13 newtons, 8.13 newtons. So it's going to be a lot easier to carry that watermelon on Io. Okay. And that was 19. Number 24 says a student of mass 45 kilograms. So mass equals 45 kilograms. It jumps off a high diving board. What is the acceleration of the Earth towards her as she accelerates toward Earth with an acceleration of 9.8 meters per second squared? A equals 9.8 meters per second squared. Use 6.0 times 10 to the 24th kilograms for the mass of the Earth. Mass of Earth equals 6.0 times 10 to the 24th kg. And assume the net force of the Earth is the force of gravity as she exerts on it. Okay, so let's find the force that she's exerting on the Earth because it's going to be the same force the Earth exerts on her. So F equals MA equals 45 kilograms times 9.8 meters per second squared. And let's see, what is that? This is chapter number 24. She's going to exert a force of 441 newtons. And now to find 441 newtons, this is going to be the acceleration of the Earth towards her, equals 6.0 times 10 to the 24th kg times A. Let's see. A is going to be something ridiculously small, but it's going to exist. 7.4 times 10 to the negative 23rd meters per second squared. So the Earth is going to accelerate towards her with a value, a magnitude of 7.4 times 10 to the negative 23rd meters per second squared. Number 28 says a 0.22 caliber rifle, 0.22 caliber rifle bullet traveling at 350 meters per second. So V equals 350 meters per second. Strikes a large tree and penetrates it to a depth of 0.130 meters. So delta X equals that. Assume constant retarding force. So that means assume a constant acceleration. How much time is required for the bullet to stop? What force in newtons does the tree exert on the bullet? Okay, so we need to find delta T. And then we need to find the force. So we're going to use that handy dandy kinematic equation. Says delta X equals V initial plus V final divided by 2, the average of those times t. So we're going to solve for t. So 0.130 meters equals, V initial is 350 meters per second plus 0, it stopped, divided by 2 times t. And t is going to be equal to 7.43 times 10 to the negative 4th seconds, 10 to the negative 4th seconds. So that's pretty fast. All right, now we're going to need to know the force. Do we get the mass of the bullet? Let's see. Must give us that, right? No? Let's see. 22, the mass, okay, the mass of the bullet is 1.80 grams, but we don't want grams, we're dealing in kilograms, so that's 1, 2, 3. So that's 0.0018 kgs. All right, we need to find the acceleration, so I'll do V final squared equals V initial squared plus 2a delta x. So this is 0, and V initial is going to be 350 meters per second, quantity squared, plus 2 times a times delta x is 0.130 meters. And so my acceleration is going to be, let's see, negative 4.71 times 10 to the 5th meters per second squared. And my force, it's going in the negative direction, so F equals negative MA equals negative 0.0018 kgs times that, all that, and my force is going to be 848 newtons, 848 newtons. You do the math, and I do encourage you to do the math. All right, 41 reads, to study damage to an aircraft that collide with large birds, you test a gun that will accelerate chicken-sized objects so that their displacement along the gun barrel is given by x equals 9.0 times 10 to the 3rd meters per second squared times t squared. A minus 8.0 times 10 to the 4th meters per second cubed times t cubed. All right. The object leaves the end of the barrel at t equals 0.025 seconds. How long must the gun barrel be? What will be the speed of the object as they leave the end of the barrel? What net force must be exerted on a 1.5 kilogram object at t equals 0 and at t equals 0.25 seconds? Okay, how long is the barrel? Do we have that? Oh no, we're solving for that. All right, let's go ahead and do that. Okay, so when at t at 0.025 seconds, we're going to solve for that displacement. So we're going to have x equals 9.0 times 10 to the 3rd meters per second squared times 0.025 seconds quantity squared minus 8.0 times 10 to the 4th meters per second cubed times 0.025 seconds quantity cubed. All right, and that is going to be 4.4 meters. So x equals 4.4 meters. That's part A. Let me clear the board. Part B says what will the speed of the objects, what will be the speed of the objects as they leave the end of the barrel? Okay, so we have a displacement, so dx dt is going to give us v, and that's going to be 18.0 times 10 to the third meters per second times t, minus 24.0 times 10 to the fourth meters per second times t squared. And if I use that value 0.025, I'm going to get v at the end of barrel is, I put in my value at 0.2 seconds is going to be, let's see, 300 meters per second. And let me pause, get some board space. Okay, now it's asking me for the net force at 0 and at 0.25. All right, so at 0, I'm going to use this. Oops, let me get a pencil. I'm going to take another derivative to get the acceleration. And I'm going to get, let's see. Well, I have v there. Let me get a is going to be dv dt, and I should have kept my equation out, but it's going to be 118.0 meters per second squared. Oh, wait a minute. Whoa, let me see. I forgot my exponent. Let me just pause here. All right, let me just go ahead and write my expression for velocity. It'll be so much easier to take the derivative there. I had 18.0 times 10 to the third meters per second squared times t, minus 24.0 times 10 to the fourth meters per second cubed times t squared. All right, so now that's v. Now dv dt is going to be 18.0 times 10 to the third meters per second squared minus, okay, that's going to be 48.0 times 10 to the fourth meters per second cubed times t. So a at 0, t equals 0, and a at t equals 0.025. I'm going to get, if I put in my values for t, the first at 0, it's going to just be 18.0 times 10 to the third meters per second squared. And at 0.025, it's going to be 6.0 times 10 to the third meters per second squared. So finding the force, F equals ma, and m is, let's see, what is m? Sure. M is 1.5 kgs equals 1.5 kg times 18.0 times 10 to the third meters per second squared. That's going to give me 2.7 times 10 to the fourth newtons. 2.7 10 to the fourth newtons. And finally here we're going to get 1.50 kg times 6.0 times 10 to the third meters per second squared. And that will be 9.0 times 10 to the third newtons. That concludes chapter 4 homeworks.